Hey guys, welcome to my channel. I'm LeetCoder, and today, guys, we have an amazing problem for you guys, right? So the problem's called flood fill, guys. So let's quickly go ahead and read the problem statement, guys. So it says an image, right, is represented by m by n integer grid image, where image of I, image of ij, right, represents the pixel value of the image, all right? So it's a 2D grid and then it's represent image, right? You know what I'm saying? So it says we're given three integers, right? Source, a row, column, right, and a color, right? You should perform a flood fill on the image starting from the pixel at that particular coordinate, right? Which you're gonna give us, right? The source row and the source column, right? So they're gonna give us that data. So it says to perform a flood fill, right? Consider the starting pixel plus any pixels connected for direct, directionally to the starting pixel, right, of the same color as the starting pixel, plus any pixels connected for directionally to those pixels also with the same color, right, and so on, right? So it says replace the color of all of the aforementioned pixels with color, okay? So he says return the modified image after performing the flood fill, guys, right? So this is a very good one, guys, right? So what they're telling us, what they're saying, guys, right? They're saying pretty much to we'll be giving we'll be given the source row and the source column, guys, right? So and the color variable, right? So they're saying that we should color the the starting pixel, which is the source, which is the row and column, the coordinate that we're given, right? We color that cell, right? You know what I'm saying? We color that cell after we color it, right? So when we just pretty much update the value at that particular cell. You know what I'm saying? So after doing that, uh, we need to also color our adjacent neighbors. You know what I'm saying? Adjacent neighbors that have the same color as as we did as that cell data right before it colored itself, right? And then we go explore those other cells, right? The adjacent cells, right? They have the same color as it did before, right? And after it does that, those cells as well will be doing the same thing, guys, which is to color themselves and also um, color all the adjacent neighbors that had the same color that they had previously, right? Before they colored themselves, right? So let's go a couple of examples. I think it'll make a lot more sense, right? So, um, so you see this first example, right? So we're given the coordinates 1, 1, right? Which is pretty much row 1, column 1, guys, right? So this is this cell that they're referring to, right? This is the source cell. This is the starting cell, guys, right? You know what I'm saying? So this is the center of the image, pretty much, that this represents, right? So the new color that we should color the new cell is 2, right? So we color this cell with a 2, guys, right? We color with a 2. And then after we do that, we also need to color the adjacent cells, right, to it, right, that have the same color that it had, right? So we have, see, we have several. We have this one and this one and this one, right? So 4 directions, up and down, left and right, right? So we have one here, we have one here, right? And 0, 0. So now those two ones, right, we'll be coloring them as well, right, with that number 2, which is the new color, right? So you see that we add 2 and then we colored this 2, this one, which is this one, right? We colored um we colored those 2, right? And then after we color them, right, they themselves, right, need to check for other colors that for other cells, right, that had the same color as it did, right? And colored them as well, guys, right? And then so that's exactly what's happening, right? So we colored this one, right? Boom, boom. We colored this one because they're adjacent to it, right? And they have the same color. That's why we end up doing that, right? So we can't go here for so once we get here, right? We can't go there because this is 0. This is not the same color as that one, right? So we don't even explore this path, right? So and then you can see that no, we discolored, and then this guy goes ahead and colors this guy, right? Or it could have been, or it could have just went from yeah. So there it was this one and this one, right? And then either one, this one or this one, will color this guy, and then since that's how we end up coloring everybody, right? So this one stays by itself, right? Because there's no adjacent ones, right? You know what I'm saying? And in the requirements, right? They do not count diagonal cells, right? So they're not adjacent, pretty much, right? So um, that's very, very important, right? So that's how we, after we color all the ones, right, that are connected to each other, I'm saying, we end up with this kind of matrix, right? So we see this one stays put. So this is kind of very similar to problems that we've done in the past, guys, which involves the different traversals, right? You know, BFS and BFS, right? Those kind of island problems kind of are very similar to this problem a little bit, you know what I'm saying? So um, yeah, so those are connected, right? That's how we ended up, guys, coloring all of the different cells, guys, right? So it's up to you how you want to pretty much solve this problem, guys, right? So we can either, you know, pretty much it's a very easy traversal kind of problem, graph problem. So we could either go to DFS or BFS, guys, right? So for this problem, we're gonna decide to go to DFS because it's a lot more simpler. It's a lot easier to implement. It's a lot more clean to show you guys how to do it, guys, right? So that's it, what we end up doing, guys, a simple DFS. And as we're traversing, guys, right, you know what I'm saying? Um, we could easily have added a so to not account for cells that we've already visited, right? We could easily add a Boolean matrix as well, right? That pretty much will be a true false, right? That will let us know if we've already visited a cell already, right? So uh yeah, so we could easily add that, right? So but we're going to be even better. Simply going to say if that color's already been if that cell has already been colored, right? We don't need to visit it again, right? So we that's how we're gonna pretty much stop the infinite, I'm saying, Stack Overflow thing, right? So this is gonna be one of the checks that we'll be adding in our condition as we're crafting our DFS function, guys, right? You know what I'm saying? So uh hopefully you guys are able to understand the thought process and the logic that we'll be applying. Let's quickly go ahead with the implementation, guys, right? All right, so guys, what we're gonna do, we're gonna have our function, guys, right, which is gonna be a DFS. We're gonna be doing a DFS, okay? So we're gonna be passing in the image. We're gonna be passing in the source row, right? I'm saying, and the source column, right? Parameters, and also we'll be passing in the old color of the cell, guys, right? Because we need that information so that we could check, you know, the different cells. Do they have that same value, right? If they have that same value, then and they're adjacent, then they need to be called as well, right? So we're gonna be doing calls upon them, all right? All right, and then we're gonna also pass in the color, guys, right? Which is the new color, right? And after we're done with the DFS, guys, we're simply going to return the modified input, right? I'm saying, okay. So now what we're gonna do, guys, we're gonna private void DFS. All right, and then we're gonna pretty much have the same signature, almost the same signature, right, as the first one, right? We have the image, we have the source, we have the column, and we have the so we're gonna call this one the new color, guys, right? New color, right? And also we're gonna be passing in the old color as well, right? So now everything should be straight, and now we're gonna have the conditions, guys. Those conditions will be if the things are out of bounds, right? So this is very simple. This is textbook stuff that we're doing. We do this for all the problems, right? This is just to check if things are out of bounds, if we're in bounds, right? It's all I'm doing right there, right? So bear with me, guys, right? So source column, right, is greater than or equal to the image that length, right? So pretty much it's within bounds. So this is to check the if we're in bounds for the rows, if we're in bounds for the columns, right? Right? And if that's the case, we return, guys, right? I'm saying. So we're gonna do a couple of checks, guys, here, right? That's gonna be very, very important, right? So if the image if the image that we're on, right, I'm saying, which is gonna know the image that we're on with those coordinates, right? This is the source and the rows and the columns, right? If that uh if that it's not equal to the old color, right, I'm saying, right? So if that's equal to, so if that image that I'm on right now is not equal to the old color, right, which is the initial color that the cell had before, right? If that's not the case, then I'm not going to explore on that path, right? Because it's not the same, because that's not the requirements, right? I'm saying, because if they're the same, that's the only way we're going to color that those cells, right? I'm saying based on the requirements, right? And then now we're gonna also add another condition, which is gonna help us and not visit a cell that we've already visited, right? So we do this check right here, right? If the image has already been colored, you know what I'm saying, right? Which will be so if it has that new color that we're coloring all the cells with, right? If it has that new color already, right? What I'm saying, if it has that, then we're return, guys, right? After we do that, right, we are pretty much in good shape. We just color that cell with the new color, guys, right? The color, and then what we're gonna do, guys, we're simply going to explore now, right? Explore on, so we need to update that to say the old color, right? And then this is gonna be the new color, guys, right? So now we just copy this 4 times because we need to visit all 4 neighbors, right? Right. So now we're going to go down, right? And then this one we're going to go up, all right? And then this one we're going to go to the right. And this one we're going to go to the left, guys, right? She's very, very similar to the other problems that we've done on this channel. So we've done a lot of them, right, so far. All right. So we do our DFS, right? We do the initial things, check the bounds, and we check if the cell that we're on, right, if it doesn't have the same color, right, as the old color, right? If it doesn't have that, then we return. Or if that cell has already been colored, then we just return from a DFS call, right? And then we color that image, I mean that cell, and we visit all of our neighbors, guys, right? Just as simple as that. Right? Let's press run code, see if we pass the small test case. Let's press submit if we pass all the test cases, guys. Awesome, guys. We passed all the test cases, guys. So if you guys found value in this video, guys, make sure to give me a like. If you guys are new here, make sure to subscribe because I'll be doing a lot of other videos just like this one. So I want to thank you guys for watching, and I'll see you guys in the next one.